All right, so I really needed to make a third video to explain this a lot better. I'm going to be using a good analogy and a bad analogy, and then I'm going to explain something else at the end that really needs to be explained. Um, all right, so when we look at light going into water, what's going on? There's fewer particles in the air than there are in the water. And that's really what slows the light down, is it's being absorbed and re-emitted. Um, and that happens more in the water. So it slows down more in the water than it does in the air. Um, and that's why we get the refractive index. When we put a straw in a cup of water, we kind of see it bend. Similar thing happens with particles. Um, with fermions, electrons, protons, those kind of particles. I guess photons are also particles. So when you think of electromagnetic fields, most people just think positive and negative electricity, or north and south poles of a magnet. That's one way of looking at it. The other way is just looking at the electromagnetic radiation, radio waves, heat waves, light. They're all the same thing. They're all visible light is just radio. It's the same as radio waves. It's the same. It's just electromagnetic waves. Um, it's electromagnetic radiation. Sorry. So suppose we have the Earth right here, and it has all these photons. So electromagnetic radiation is pretty much just photons. That's what it is. It's photons. They don't have to be positive or negative. They're just photons. So the Earth has all these photons around it. It's from the electromagnetic radiation that it produces. And it's more dense towards the Earth than away from the Earth. So when a particle comes by, it's absorbing and re-emitting these photons. And every time it does that, it slows down. So as a particle is going this way, it's going to slow down more towards the Earth, and it's going to veer towards the Earth because it's absorbing and re-emitting these photons. That's why it's slowing down. Its time is slowing down more towards the Earth. It's a similar concept as light going through water. So particles absorbing and re-emitting photons cause photons to slow down more in an area that's dense with particles. So a higher particle density causes photons to slow down more. A higher photon density causes particles to slow down more. So the photons slow down because they're being absorbed and re-emitted by particles. Particles slow down because they're absorbing and re-emitting photons. And a higher particle density makes photons slow down more, and a higher photon density makes particles slow down more. And when I'm talking about particles, when I say particles, I mean fermion particles, not boson particles, not photons. So that's the good analogy. The bad analogy is, it's just another way of looking at it, is the molasses analogy. So, for example, this is the Earth, and imagine there's like molasses around the Earth, and the molasses is more dense towards the Earth, and it thins out away from the Earth. As a particle is going this way, it's going into the thick molasses, and it's going to veer towards the thicker molasses. Now, that's the bad analogy, because I don't like looking at it as molasses, because that just raises a bunch of other questions. but it's just a more intuitive way of kind of understanding how the slowing down of time causes gravity, I guess. Um, Now, the $1 million question is, well, what about photons that go towards gravitational sources? What about gravitational lensing? Light doesn't interact with light. How would a photon's path bend if it's not interacting with the other photons? Well, that's when we go into Feynman diagrams. So we do know that as light travels, it spontaneously goes from photon to electron positron pair, and then from electron positron pair to photon. So creation, elimination, photon, creation, elimination, photon. And how often does light do this? Well, all the time. It virtually does it all the time, infinitely many times, all the time, as described by Richard Feynman. I mean, that at least that's what he taught us, is that this happens all the time, and it's just a statistical probability of how often it happens, but it does happen infinitely as the light travels. It creates electron positron pairs, and then they annihilate and create a photon. And it's in this creation annihilation process when they pass through the electromagnetic sea molasses, if you will, whatever. It's during this creation annihilation process when it becomes an electron positron pair. That's when they will interact with the photons, and that's how you get gravitational lensing.